Hi and welcome. I hope everyone is okay. If you remember that we stayed in this topic comparing different data representation, and we will go on from there. Now we solved some problem about comparing different data. If you remember, you have qualitative data. You should use pictogram, vertical line graph, bar chart, pie chart, sectional bar chart. And if you have quantitative data, you should decide this data is discrete or continuous data. If you have discrete quantitative data, you should decide ungrouped or grouped. If you have ungrouped discrete quantitative data, you should use pictogram, vertical line, bar chart, pie chart, or sectional bar chart. If you have discrete quantitative data and if you decide this data is grouped, so if you have small amount, you should use stem and leaf diagram. If the group is large amount, so you should histogram or cumulative frequency graph. If you have continuous data, you should use histogram or cumulative frequency. And we state the last question about comparing the different data. The question about votes cast for the 5 election candidates. The proportion of votes cast for the 5 election candidates A, B, C, D, E are represented in a pie chart. The chart has sector angles 25 degrees, 86 degrees, 92 degrees, 58 degrees, and 99 degrees, which are labeled A to E in that order. Explain why, from the information given, it's not possible to tell how many more votes candidate E received than candidate A. Because if you pay attention that they give us only sector angles, they didn't give us the number of votes or cast for the elections candidates. So we don't have the number of votes cast, so we don't decide this section. And the second one, the winning candidate's son wishes to represent the votes cast for the candidates in a cumulative frequency graph. Give a reason why this type of diagram would not be appropriate in this case. Please remember that the start of this diagram, if you want to use cumulative frequency graph, you have continuous data, and your data should be grouped. But if you look at this question, your values is not grouped and not quantitative data. So these values reason of the not quantitative data, we don't draw any cumulative frequency related to this situation. Okay, now we have a homework about this topic, and I want to tell you about this homework. I want you to do solution which exercise 1C. In your textbook, 1C exercise, page number from 16 to 19, and 1D exercise, page number from 21 to 23, and the end of the chapter review exercise, page number 24 and 25, were in your textbook. And I want you to this exercise solution you should do on your notebooks, and please pay attention that the last date is the 20th October for this homework. 20. Today is 11th of October, and 9 days later is the last date. And I activated this homework in your Google Classroom after you have to upload what you wrote thereby taking photos on your Google Classroom account of what was written. And don't forget that the students who upload their homework in time will take 100 scores, but the scores of the students who don't upload homework in time will decrease by 20 points for each day. Okay, now we can pass the other topic. The other topic, excuse me, is chapter 2. Chapter 2 related to measures of central tendency. Measures of central tendency also you learned previous years, but in this year we will learn the different part about mode, mean, and median. There are three measures of central tendency that are commonly used to describe the average value of a set of data. These are mode, mean, and median. The mode is most commonly occurring value. The mean is calculated by dividing the sum of the values by the number of values, and the median is the value in the middle of an ordered set of the data. And we use an average to summarize the values in a set of data. As a representative value, it should be fairly central to and typical of the values that it represents. If we investigate the annual incomes of all the people in a region, then a single value, average income, for example, would be a convenient number to represent our findings. Deciding which measure to use depends on many factors. For example, the mean is most familiar average. A shoemaker would prefer to know which shoe size is the most popular. If the shoemaker wants to this situation, he or she measure that mode because she wants to which shoe size is the most popular. As for the average income in our chosen region, we must also consider whether to calculate an average for the workers and managers together or separately. And if separately, then we need to decide who fits into which category. And the first step, we will review the mode and model class. As you will recall, a set of data may have more than one mode or no mode at all. For example, if if your value if your values are, excuse me, if your values are, for example, 0, 0, 1, 1, 1, and 2, 3, and 4, 4, 4, 5. If you look at these value, you have 3 times 1, and you have 3 times 4. And these amounts different from the other values. And in this data you have two modes, also more than one mode. These modes are 1 and 4, because both of them again 2-3 times. But if your values are, for example, 0 0 0, 1 1 1, 2 2 2, and 3 3 3, all values amount the same. So this situation, in this value no mode, because all values amount are the same. So as you remember that a set of data may have more than one mode, for in the first example, or no mode, the second example. The following table shows the scores on 25 rolls of a die, where 2 is the mode because it is the highest frequency. Please pay attention that one die 5 times come, and two number comes 6 times, and 3 number comes 5 times. The number of 4 comes 3 times, and 5 comes 2 times, 6 comes 4 times. So two number, the number of 2, the highest frequency, because 6 times comes 6 times. So the data our mode is 2. And sometimes we may no have these data. We may have a frequency density. Please remember that frequency density we used to in histogram. If you have a frequency density, how you will find a mode. But in the first step, don't forget, it's called no mode. In frequency density, it's called model class. For example, in a set of grouped data in which raw values cannot be seen, we can find the model class, which is the class with the highest frequency density. Previously example, we can see the all values how many times come, and we can decide which is the mode easily. But sometimes we can't see the values how many times which are the frequency. So we should use frequency density. I hope in these worked you can understand easily. For example, find the model class of the 270 pencil lengths given to nearest centimeter in the following table. Okay, now in the first group, between 4 and 7 length, we have 100 pencils, but we don't have any information how many pencils 4 centimeter, 5 centimeter, 5.7 6 centimeter. So we can't see the exactly value. So if we want to find the mode, it's called other name model class, we should use frequency density. But we need to arrange a new table, because if you pay attention, our values discrete values, but it should be continuous values. And if you remember that our interval, for example 7, the first group, the second group lower boundary is 8, and the interval is 1, the interval is 1, and 1 divided by 2, and it becomes 0.5 or half, and we should start minus 0.5 and add 0.5. For example, for the first group, 4 minus 0.5, 3.5, greater or equal than x, and less than 7 plus 0.5, less than 7.5. And the second group greater or equals than 7.5 and less than 10.5. And the third group greater or equal than 10.5, less than 12.5. Okay, it became the continuous value because the interval was 1, and 1 divided by 2 became the 0.5, and we start to 4 minus 0.5, it's also 3.5, and for 2 7 plus 0.5, 7.5, and we went on this section. And the number of pencils, it's also the same. And the first group, we have 3 pencils, 100 pencils, excuse me. The second group, we have 9 pencils and 8 pencils. And please remember that our columns width is 7.5 minus 3.5. So it's equals to 4, and 10.5 minus 7.5, our width is 3, and 12.5 minus 10.5 and 2. And please remember that how we compute the frequency density. If you frequency over width, you will be compute frequency density. So, and 100 divided by 4, frequency density equals to 25. 90 divided by 3, frequency density is 30. 80 divided by 2 and equals to 40, frequency density is 40. And if you want to decide which data is model class or this question, you should decide to the last class, because the last class frequency density highest than other. So the model glass is 10.5 greater or equals than less than 12.5. The model glass we can decide to easily. And the other question, two glasses or data have interval width in the ratio 3 and 2. Given that there is no model glass, please pay attention that we have no model glass. In the question, no model glass. And please remember that uh, how we have a situation we would don't have model glass. If you remember that if you have no model glass, all values amount should be the same. So the model glass, no model glass in this situation, all frequency density the same. All frequency density should be the same. And that the frequency of the first glass is 48. Find the frequency of the second glass. And you know we can compute the frequency density means frequency over width. So in the first given that the ratio width is 3/2, and if we want to be a frequency density, it should be equals ratio and frequency number. And this frequency number 48, the second glass frequency number x should be x. And now if we want to x, we should compute this section. 2 multiply 48 equals to x multiply 3, and 96 equals to 3x, and x equals to should be 32. And the second class have 32 frequency, and because it should be the same frequency density. Another solvation that you should you can solve this problem. Interval width 3 and frequency 48. So frequency density frequency 48 over width 3 equals to frequency, the first class, please don't forget first class, and the second class frequency density, and frequency 2, excuse me, interval with 2, frequency, I don't know, x over width. The width is 2, and the same section, the same process, and 2 multiply 48 equals to 3 multiply x, and then 96 equals to 3x, and x equals to 32. The same value our solution, in our solution. And Now we have an example, one more example about mode and model class. Find the model class for x and for y in the following table. Okay, now we should arrange arrange about the given tables. For this table, I will draw a new graph, new table, and we have x value and the frequency of x, the second part, and we will need to width, and we will need to frequency density. Okay, now the first box is x value, the second one frequency and width, and the last one frequency density. And if you see the like this, it means that the lower boundary in the first group, the lower boundary is 0, the upper boundary is 4. If you see the second group, the lower boundary is 4, the upper boundary is 14. So you should arrange the x value again like this: x greater or greater and equals than 0, less than 4, and the second group x greater and equals than 4, less than 14, and the last group x greater and equals than 14 and less than 20. Please pay attention that if you see these values, you should arrange again a new boundaries. And frequency also 5, 9, and 8. And width, 4 minus 0, 14 minus 4, and 20 minus 14. 20 minus 14. And frequency density, our formula is, for frequency density, is frequency over width. So 5 over 4, it means 1.25, and 9 over 10, or 9 divided by 10, 0.9, and the last one 8 divided by 6, and approximately that 1.33 go on. And the highest frequency density of the last group. So our model class for this table is the third class. Our model class is third class, 14, between 14 and 20. Okay, now the other table. According to the other table, we solved this problem, and I want to add a new table, a very short, according to first table. And okay, now we have two more parts. Also first with the second, the other frequency density. and we should compute the width, and we should compute the frequency density, but pay attention that these data not continuous. We need to make continuous data, and the interval, the lower boundary minus the upper boundary 1, and 1 divided by 2, 1 divided by 2, 0.5, and we should use 2.5 and 6.5, 6.5 and 11.5 and 11.5, 11.5 and 20.5. Okay, our width 6.5 minus 2.5, 4. 11.5 minus 6.5, 5. 20.5 minus 11.5, 9. And our frequency also the same. And a frequency density means a frequency divided by width. So 66 divided by 4, 8 divided by 5, and 134 divided by 9. And it's approximately that 16.5 is accused that 16, and like 14 point, approximately that 14.8, and the highest frequency is 16.5, and it has the first group, and according to this table, our model glass is the first glass. Also x greater and accused than 25, less than 2.5, less than 6.5. The first glass is our model glass about the second table. Okay, now we learned mode and model glass, and different way and different part of in the two section. And I want to remember you something. I sent to a homework, and the time I make your homework date rearrange, and I will wait your homework on this due time. In this lesson, for now finish. Have a nice day and have a nice lesson.